Hello to all of you out there. Hopefully you're enjoying the conference so far. My talk is last one before the keynote. So I welcome everyone who's joining first time for my talk, and the people who attended my previous talk 2 hours ago, well, welcome back. And this time we're going to be talking about new trends and continuous delivery, pipelines implementation. And I do have a warning for you, a little bit of warning, that as many of you today, I do work from home and have to present from home with the kids running around. So if there are any background noises, sorry about that. And with this presentation, those slides are rather new. So it's going to be a little bit of a journey today. And with any journey, we need to understand where we came from, to understand where we are, and to probably find the right path to the future. It's very relevant with the ongoing situation with the virus, and in many things in life, it's quite applicable. So before we start, it's me, Andrey. I'm an independent consultant focused on continuous delivery, DevOps, infrastructure automation. It's more than 10 years of industry, and I'm fixing automation projects and organizations, also as organizing meetups and conferences, such as cloud native meetups, HashiCorp user group meetups. I speak quite often, like today. I do train people in Git, Jenkins, Docker, Kubernetes, what have you. And I have plenty of certifications, but that's not the point of this presentation today. So what could you expect? I'm not pretending to be an expert, and I'm sharing my observations based on consulting practice over quite a number of years, plus based on a lot of conversations with other consultants. It's not really a technical talk. It's called relax and enjoy, so it won't be like Terraform listings as it's been in my previous one. And slides will be available online, so you don't have to really do a screenshot or anything. And what we're gonna do is we're gonna do a little bit of digital archaeology, or at least we're gonna try to follow my attempt to do that in order to understand where we are today with continuous delivery. But in order to understand that, we have to see where we came from. And the first point that I wanted to highlight, we could start earlier, obviously, but I think it's fair to start here with Kent Beck and the book Extreme Programming, where he went into some detail about continuous integration. And I believe that was one of the first serious mentions of continuous integration. There might be presentations on a conference, but a little bit hard to find this information. So I'm trying to find some big events or milestones that you can say to put them on a timeline. So that's a book this time. And in 2000, Martin Fowler expanded on the topic and provided a really nice article describing continuous integration. And he identified a couple of practices that you have to be doing to say that you're doing continuous integration. So those categories here in the bold, that's like my attempt to group them. And they all make sense now in foresight. But probably one thing that I should be clarifying here, he's saying maintain a single source repository. He doesn't really say do a monorepo thing. Here it means that you have to version your dependencies in order to make sure that you have repeatable builds. And then all other stuff is pretty much what you expect from continuous integration today. So everyone commits to the main line, the primary branch. Everyone's changes go through the build machine, integration machine. You're keeping your build fast. You automate the build. You make a build self-testing. You fix broken builds immediately. And that back in 2000, because in 2000 they didn't really have anything like a PR flow where you would test on the branch first and then you merge. And in 99%, your primary branch build is always green. No, before that, people would commit to the primary branch, and then they would find out that, well, something is broken, and so on. So in 2005, we are getting this beauty, and yeah, there are numerous opinions about Jenkins, Hudson. Well, Hudson eventually became Jenkins, and how people like or don't like it. I'm gonna leave it outside this presentation, and we're just gonna use Hudson as a open source tools that actually went through the whole transformation, the whole story. So we could use that to track what's going on. And if you don't really like the Jenkins design or Hudson design, I can understand that but it came as alternative to this. So everything is understandable is in when you compare to something. So what people had back in the day, like early 2000s, since we didn't really have as much compute power as we have today, and the builds was much slower due to the issues with the build tools, as I mentioned, lack of the processing power, and general methodology comparing to what we do today. So people would usually do like cron builds, so most often daily builds. So you would run all your builds during the night. In the morning, you find out that the branch is broken. You come in and fix it. So that was a primary approach back in the day. And it came to the issue because you have a delay before you find out that stuff is broken, and people keep building on top of the broken baseline. So when you fix the issue that you see on top, it might be so that you have another issue sitting in there, and you might go for a couple of days without having a working build, which will rather delay your testing, causing the quality issues and slide of the project. So it wasn't ideal, really. What you could also do back then, even like with the first versions of Jenkins, you could do a downstream. So you could have a job that triggers another job, and then you have a possibility to slice the builds in smaller pieces, and maybe do the most important thing first, less important thing later. So it starts to look like a continuous delivery pipeline, but very primitive, I would say. In 2005, we get in Git. In 2008, we get in GitHub. And it is important because of a couple of reasons, as we're going to see. First of all, in 2009, so like pretty much next year after GitHub became available for us, we got the Jenkins plugin. And that changed the way we interact with the triggering of the pipeline. So we got the possibility to have webhooks. I'm not saying that we got that in 2009, but eventually. I'm just trying to highlight events that influenced the way we do continuous delivery today. But still, with Git and GitHub and similar tools like Gerrit, we got a possibility to trigger pipelines on event. It could be so it was possible with CVS back in the day or SVN, but I will leave that alone, and Git won overall. So then also in 2009, we're getting the trigger plugin where you could pass parameters between jobs. So it increases your flexibility of what you could do, as well as a join plugin. So you could do something, here's a join plugin. And so you could do something like this. So you can fan out and then fan in, and you can run more builds, more tests in parallel. So that our pipelines becoming a little bit more sophisticated. And then you could even do like that. So you could run more stuff in parallel and build quite complex pipelines. But back in 2010, 2009, that was hell, really. So you didn't have any infrastructure as code or anything. You would go in Jenkins and click around and configure all of your jobs to trigger one another. And then you have a brilliant idea how to restructure your flow. And you have to do that during the weekend. So you don't interrupt development flow, or you have to copy it somehow and change it. It was a mess, really. And I spent quite a number of weekends redoing those pipelines in UI. And yeah, I'm not looking back. Like, not really want to do it anytime again. And also around that time, I kind of struggled to point out the particular dates, but also with those pipelines, we also had a different type of strategies being discussed when it comes to deployment. So already then people were discussing blue, green, canary, doing the traffic mirroring and not returning the responses like a dark deployments, also discussing feature toggles and flags. So for instance, I found an article on feature toggles by Martin Fowler in 2004, back then, saying that, well, you shouldn't be really doing the release feature toggles because you do that if it's your last effort. 10 years later, we have launched Darkly, starting as a company, providing exactly that as a service. So, fun time. Also in 2009, first DevOps Day is happening, and it gives a bigger kick to the whole thing. Not exactly continuous delivery, but all the talk around automation, getting to work closer between development and operation, and so on and so on. So it was an important moment. Also in 2009, we're getting EC2 plugin for Jenkins, which means that, well, 2009, people were already using EC2s to provision, for instance, workloads like the build agents on Amazon. So this is something we can point out based on plugin release. I mean, the plugin was released, meaning that someone had to use it. Also, now we're approaching 2010. We have a successful Git branching model released, and many people came to realize that it wasn't so successful as stated in the title. Science, it was a little bit of overkill with all those branches. However, like still now I'm finding people using this model, which is strange, but well, people do it. I couldn't really point out the date for where we could say that the trunk-based development happened, but with advent of Git and GitHub Flow and Git branching in general, the trunk-based development became much more accessible, and generally branching became much more easier. I remember ClearCase days where we had a person whose full-time job was to merge branches because it was that hard in ClearCase, and it was so time-consuming. Git was a revolution, and with Git branching, we got a possibility to do a PR flow, like the pull request flow, where we would push to the branch, test it before we merge to the main line, and do like a pre-check, pre-integration of changes before they came into the main branch. And by doing so, we kept main branch much greener, meaning that every day we have something to test because we can build the main branch. So that was a big deal. Also in 2010, we getting Packer and Vagrant, tools for building virtual machines and development environments and virtual machines. And it is significant because we had, as you just saw, we had EC2s coming up as build agents for Jenkins, but you also need to have a reliable way of building them. And Packer was that. Packer allowed you to build IMIs reliably and reuse them instead of every time you boot the EC2, you run something like Puppet or Chef to provision it, repeating that all over again. So yeah, that was a big step forward. In 2011, finally, we're getting the continuous delivery book released. And this is, it doesn't mean that we have 2011 as something that originates continuous delivery as a term. Quite opposite. Continuous delivery was mentioned in Agile Manifesto back in the 90s. One of the Agile principles states that the priority of the development team is continuous delivery of valuable software to the customers. I'm paraphrasing, but the meaning is very close to that, and it says continuous delivery in there. So in 2011, we got a book that summarized work of a number of people and experiences for the number of years coming before that, but it was still kind of on the fringe of the methodology, technology. So I was quite brave ideas by then. Very little people were considering. I mean, continuous integration was a big thing, 2009, 2010, 2011. And now you have a continuous delivery as a next step. So that was a big eye-opening for many people. And as you might notice, like 2009, 2010, 2011 was a quite condensed years. We had a lot of stuff going on there. This is how visualization looked like in 2011. And it got somewhat better, if you can say so. But at least we had some way to visualize the pipelines. And again, here you can see that people actually calling that the pipelines. So the term is already there. People kind of getting the idea of continuous delivery. In 2012, there was a build flow plugin for Jenkins that allowed you to describe your pipeline in Groovy and apply the Groovy logic into steps. So you could have cycles, you could have conditions, and you could run a lot of stuff in parallel. That was a breakthrough, I would say, because even this one would still utilize the downstream jobs. It just would visualize that you still had the same mess configuring it. About the same time as a build flow plugin, there was a job DSL plugin that allowed at least automate generation of jobs, but yeah, they're all times. So you could do something like that. For instance, you could do a conditional steps like a build avoidance. If you had a change in a very big repository and the stuff that have changed didn't really affect the part that you have this branch for, then you could skip this branch saying, yeah, there is no branch, and there is no change for this branch, so we probably don't have to build it. 2012, we have a presentation by Adrian Cockcroft about the Netflix doing all possible mind-blowing stuff in production, and you see AWS public cloud in production 2009. That was quite an eye-opener. I mean, the whole public cloud idea was somewhat new back then. I mean, they're using GitHub, they're saying they're using continuous delivery, they're using DevOps in there, and what's going on? And this is was a boost for many companies to say, well, if they do it, we probably can too. And there was quite a push back then. Also in 2011, 2012, we have a new breed of CI tools coming out. And so there are more. I mean, you have, I mentioned here, Travis, Circle, Drone, but a little bit later you got Concord CI, and you could probably come up with a number of other names, but I'm just highlighting a few that are mostly well heard of. And they were different. I mean, Jenkins came in as something you would host yourself. It was like a Lego bricks that you could build something. You could build whatever with that. And you have access to JVM, and you can hack things around in Groovy and so on and so on. That was quite different. It was SaaS mostly. You could host it, but it came a little bit later. There were like almost no server configuration comparing to Jenkins, where you would have to configure quite a lot. You would have a build slaves as a service, build agents as a service, is how people call them nowadays. And I think the biggest difference there was you have a YAML-based declarative pipelines. That was a big thing. And also your pipeline would be stored together with your source code, comparing to in Jenkins, you have all the pipelines, all the logic on the server. And I think that was a fundamental shift where we get stuff moved from CI/CD server closer to developers, allowing developers to be the part of the cycle and change the pipelines. And that's important. And that's a contribution of those tools to the whole thing. In 2013, we're getting Docker, and that changed quite a lot how we package software. And you could think of Docker in many ways, but I see it as a way to package software and its dependencies. Before that, we would build RPM packages, PyPy, X or Wheels, or whatever you have, the var files, distribute them to Artifactory. And with Docker, everything became much more simpler. you would install all your dependencies in the container. You would have unified interface between developers and operations, allowing to bridge that gap again. So your developers can run the software exactly in the same way as operations would. And also they can collaborate on a Docker file if necessary, applying the code review. So it was a big breakthrough, and we should give a credit to Docker in the way how it's changed the way we package software and how we distribute software today. So also in 2013, GitHub starts to come up with a chat ops and advertising that as a way of working. Also in 2013, we have Slug popping up. So it's becoming available as well as a Slug plugin for Jenkins. And I think the biggest change we see today is that through the chat ops, we could have pipelines integration into our chat operations. So like, for instance, your pipeline can run towards a certain step, and then you will have requests popping up in the chat saying that, well, I'm ready to deploy, shall I? And then you can give an approval, for instance, and you will have a log of who approved what, and it's more integrated into your workflow. You could also trigger pipelines from Slack. Some people do that. I don't really see a lot of that going on. So like what I see mostly is notifications coming to the chat and approvals. Some people do more advanced things, but I don't see a lot of that happening really. Maybe it is to come, who knows? In 2013, we're getting Jenkins file and the Jenkins pipelines. So the Jenkins basically catching up with the new kids on the block, providing the same capabilities, providing the way to store your pipeline together with the source code. However, it wasn't declarative, it was imperative in Groovy. And there were a lot of ways how you could shoot yourself in the leg really with Groovy stuff. Like for instance, if you don't know, if you take the Groovy map and you say get something out of it or default, but you just say get name of the key and then value to get if the key is not there, Groovy will mutate the map and add it there. And you don't really see that coming. And there are a lot of surprises like that in Groovy. So that in that sense, YAML was much safer option for the regular Joe who would be a developer, not really familiar with all this shebang going on in Jenkins. So people could build pipelines and don't hit all those frustrating things with Groovy and imperative things getting in the way. 2014, 2015, we're getting Go by Saltworks. It actually was available for quite a while, like back in 2009, called Cruise, but in 2014, Saltworks open sourced it. So I mark it here because it became available to general public. As well as Spinnaker is coming out of Netflix in 2015. And those tools are focused on the CD part of things. And there was also something new. So for instance, Go CD came up with a value stream. So you have like resources that come into the build, like a commit, and then you see how it all progresses, giving you end-to-end view of things. Like the visualization was much more superior comparing, for instance, to Jenkins. And also Spinnaker focused a lot on deployment strategies that you would have to hack away in other tools. So providing you a little bit of platform capabilities there. Well, in 2014, we're getting Kubernetes, hard to miss this one. And the war of orchestrators kind of was going on. It was Docker Swarm, Mesos, Kubernetes, but within a year or two, it all came down to Kubernetes, basically. Everyone said, all right, Kubernetes won. And we got Kubernetes as a new deployment target. So which again affected how we run pipelines. The first change was the public cloud. So we could deploy to public cloud to the VMs running in the cloud, but it wasn't as different comparing to deploying to virtual machines running on your bare metal servers. But with Kubernetes now and with Docker around, we getting completely new target to deploy to, which your pipeline should account. And in the long run, it's going to affect the way we do pipelines even more. And like around 2015, I'm joining the company called Fragment to do consulting together with them. And they used this picture to explain continuous delivery. And I feel that after 25 minutes of saying continuous delivery, I would probably have to explain what I mean by that. And this picture sums it up quite nicely. So what you have is you have agile development, you have sprint planning, you have tasks on some kind of task management system. You have a developer picking up the task, considering himself done when he's done coding, but he's not really done. He has to be done. So his product owner have to be agreed that he's done, but his first step would be to push his change to the version control system, where we could have this pull request flow. We would take his change, we would run integration, maybe try to merge it on a separate branch, try to merge his change and the primary branch he's targeting at, and then try to run build, maybe some unit tests. And if it doesn't work, we would reject it and return to developer. So he could repeat this iteration until our gating criteria is met. And when it's done, his change will be merged, and that will trigger the pipeline on the primary branch. And that we can consider a continuous delivery pipeline that would do more stuff that is actually not fitting into your continuous integration. So you would do metrics analysis, deploy, maybe some security measures, functional tests, documentation, maybe manual tests, validations. And those steps are not full list. You could do much more. The only constraint you have is time, right? You want to have this pipeline as fast as possible so you can give a feedback to developer, preferably the same day, so he still have a fresh memory of what he did, so he can go back and fix the change or like revert the change, whatever. Since if it takes longer than that, like if the whole thing to produce a release candidate takes a week, then you just accumulate a lot of changes, and then you will have to do issue triage to understand what went wrong, create trouble reports, send them to developers trying to figure out what happened. And it's a mess. It takes a lot of time. But if you keep this continuous delivery pipeline running on every change, you have one change difference. If something breaks, you know this change broke it. It's much faster to fix it. And that's one of the big advantages that you have. You're somewhat ready to release all the time. And then you have your business owner saying that, or someone like who understands the business can say like, well, that's a good time to release. You don't really want to release all the time. You can do continuous deployment and deploy every change. For instance, if you do to the backend, some people do. But for instance, if you do a mobile app, you probably don't want to send every commit out to Apple Store, right? Because then your users will hate you because you have all these updates and you always have to download the update. So it's the balance. You need to find a situation where the gain for the business will be the biggest. But still, being in all this releasable candidate state puts you in a really good spot, because you could send out experiments, you could rapidly react on the market changes, and so on and so on. So this is a competitive advantage. Well, back to our timeline, 2015, I think Sonatype, the company behind Nexus, starts to peddle the DevSecOps term, and we give the credit to them for this. And this is about to, bring the security people out of the basement and let them join the party and include the security part in the pipeline and test for security earlier. So that's the whole idea in short. 2016, we're getting the infrastructure as code. And that's, again, this is the same with as a continuous delivery book. Continuous delivery did a summary of what some people were doing before 2011, and just summarize the best practices and ideas of how to approach that in 2011. The same as infrastructure as code. With advent of the public cloud and availability of APIs to call, we got the possibility to do infrastructure as code on a more larger scale, covering more and more systems we run. So in 2016, there was a book that summarized what it is, configuration drift, and all this stuff. And that was important, and we're going to see why. You might ask, well, what about the Puppet that came out in 2005? Chef that came out in 2009, Ansible in 2012. Well, all those tools were initially configuration management tools, and not just configuration, but server configuration management tools. You would have your bare metal server, virtual machine, and then you would run your Puppet Chef. Ansible would have you to deploy software that are using those. So it was, and also configure those servers. And it wasn't really infrastructure as code as such. And it is contagious topic. You could argue otherwise, because, for instance, Ansible eventually got plugins or extensions to call AWS API, so you could use Ansible as an infrastructure as code tool. But I would argue they initially were configuration management tools, and with advent of infrastructure as code and immutable infrastructure, where you would bake your golden images and just delete whatever you had and flash a new image, you're having less use for that. But there are cases out there where you cannot really do what I just described, and then you could still have a use for those tools. But this is my opinion, so I'm pretty sure that there are a number of people who could argue otherwise, and it's fine. All right, rolling along. 2016, you probably haven't heard of this one. I worked in Ericsson for a little while, and within Ericsson, there was this idea of AFIL protocol for intercommunication of CI/CD systems. An idea there that you would have your CI system or CD system emitting events to the message bus, like a new commit available, new artifact available, new test finished, new build finished, stuff like that. And that would allow multiple systems to interact with each other, like we have decoupled, loosely coupled architectures today, right? Interacting all with data streams or message buses. The same idea applied to the continuous delivery pipeline. And Ericsson had that case where they would need to build a base station, right? And you will have 5,000 people working every day doing a lot of software that goes in there. And you have to collect all that software from all those people, build it all together into the firmware and flash it to the base station. It is complicated stuff to achieve when you have such large scale. And you will have a small continuous integration machineries here and there producing artifacts. And they sought to use AFIL to get traceability and to have insight in what's going on, to be able to estimate the deadlines, to find the bottlenecks, and also to have operability between departments. So department can just publish the message saying, I have a new artifact, and another department, all right, I react on the message. I don't really need to have a handover between the people. The Jenkins could be triggered on those and then just fetch the artifact and keep building. So you could have a propagation of the change through the whole organization, which is quite interesting idea. A couple of big organizations looking into that, but I don't really see a lot of traction because it's a use case for really big organizations doing complex stuff. So. Right, rolling forward, 2017, we're kind of approaching the modern time now. So we have Flux CD, Argo CD, and Jenkins X. All of those running in Kubernetes, being the primary distinction to what we had before, and say doing the kind of GitOps. And we could say that we have a little bit of war or a little bit of wrestling under carpet between those tools. When it comes to GitOps, they're trying to scream louder and louder. And Flux came out of Weaveworks, and I think the Weaveworks were the first ones to talk about the GitOps, then Argo, and then Jenkins 6 came about. And by GitOps, people mean that you would run your pipeline as you would usually do, and you would store your container images in the image registry, and you will also generate your Kubernetes specs, and you would commit them to repository, and you would have operators sitting within Kubernetes watching that repository, and as soon as there is a new update to the spec already pre-generated, Kubernetes would take that spec, compare it to what is there, and basically try to apply it, right? And then get to the described state. So it's different in a way comparing to the typical pipeline. Typical pipeline, you have a server, CI/CD server controlling the flow. and allowing you to, and basically CI/CD server will be calling Kubernetes API to send over, so it will push those specs. Here you have Kubernetes itself pulling specs in. In some way, it's actually more secure because your CI/CD server doesn't need to have exposure to Kubernetes API, and the whole communication goes over the Git repository, basically. Also, you have a full snapshot of your system running all the time because you save, I mean, like with Helm, you generate, you do templating and you generate YAML files, and then those YAML files apply, but you not always really save them. And with GitOps, you actually have those saved, and you can easily roll back to the previous state. So there are good sides to this, but my primary concern to here is that as a developer, I would like to see end-to-end life of my change. So here I committed it to the branch, and I want to see a green mark that it's running in production here. And with GitOps, it's kind of a little bit harder to get there because before that you would have the life cycle of your change tracked in a central server like Jenkins, for instance. You would have a pipeline outlining all the steps and how they went. And now Jenkins just pushes it to the Git repository and says, well, I'm done. Or you have to build some kind of monitoring all around the steps that would pull Kubernetes API to tell you that the change actually happened. So there is like no in-place tool to do that and to provide this visibility. So maybe it's changing in a way that your GitOps server running in Kubernetes would send you a Slack notification, and then Slack becoming your pipeline representation, right? So then your Jenkins server is just execution environment, your GitOps server is just execution environment, and you track the state of your pipeline in Slack. Maybe then we're just having like defragmentation of the system. I don't know. It's quite a new concept, and we're going to see how it evolves. And in 2019, Flags joined City with Archaeology, becoming the same thing. So good. It's good because then more clever people working on the same thing, and everyone hopefully getting a better outcome. And there is still Jenkins 6 around. Also in 2019, we're getting the Continuous Delivery Foundation that's supposed to bring some order and maybe new directions to how we do continuous delivery. And it started with the open source projects of Tekton, Jenkins, Jenkins, and Spinnaker. And Tekton itself is an idea of building pipelines using CRDs and Kubernetes. Quite interesting, I would say, quite new idea. I'm not really sure that the Kubernetes object model is really suited for the build because you cannot declare your build that is passing, right? Build is something that's happening. So you start the build, it's like a job you started, and then you don't really know what the outcome is going to be. And with Kubernetes, you have a declarative infrastructure. You declare that I want to have that many pods. A little bit stretching concepts here, but Kubernetes has a job concept, so maybe, but well, we're going to see how it evolves. Again, the whole thing quite new, and we have to watch it. Also, another concern I had, like with GitOps, that people mostly thinking about Kubernetes, but like I'm a big fan of Terraform. How do I do with my Terraform? And look at this. Just a week ago, we're getting Terraform operator for Kubernetes. So basically, we could do the same type of thing with Kubernetes. With Terraform now. So we have something running in Kubernetes that would call Terraform when we get update for our Terraform specs. Why not? So it looks like another step towards GitOps becoming a dominant player in the way how we build pipelines, but we have to see again. It's a quite new area. Also, the Kashuki Kawaguchi, leaving CloudBees, the company behind Jenkins. Well, the company that supports Jenkins mostly now. And he starts a new company called Lunchable. And this idea about intelligent testing that like you run, at some point you have like thousands of tests, and you don't really have to run all of them. You have to see what changed, and then see what tests are failing more often, and then build a dynamic test suite that would allow you to run most valuable tests first and less valuable tests later. For instance, running tests that do not involve changed parts, but still test for regression later in the pipeline. So you minimize time to feedback. So I think it's a great idea, and I'm surprised that no one did it before. So we have to look for this one. And with that, we're arriving to today. So are we there yet? And I'm trying to answer this question to myself because, well, when I speak to customers, when I speak to my friends, it looks like the people doing the continuous delivery all over the place. I even were in Göteborg once, and I spoke to the guy, quite young, from the university, fresh from the university, but he was working for a couple of years now, and he never worked without continuous delivery, so he doesn't really know how it is. And I had to explain, like, well, working without continuous delivery, like you have all those steps that done for you by Jenkins, you do it manually and do a tons of mistakes while doing that. And he was like, why people would do that? Yeah, so we have a young generation coming up actually who knows what and expects continuous delivery to be in place, but there are still like companies adopting that because still like back in 2017, 18, 19, I had conversation with people that trying to convince them that they have to do continuous delivery. And so are we there yet? I'm not sure. Like, it's really hard to find any statistics. Should we be doing technology bets? Like, for instance, GitOps, like, should we do a technology bet and start adopting GitOps now? I don't know. It depends, and we're going to come back to that. Then riding hype waves, like going to KubeCon, it feels to me like riding a hype wave nowadays. There are a lot of people who, like, I look at them, it feels like they don't really know why they're here. They heard about this Kubernetes thing going strong and they came, but it's like so much stuff going on. And again, I think we have to keep the cold head here. And we're going to have another slide on this. Then we have last 5 years feels a little bit slow if you take 2009, 10, 11, 12, like was a lot of stuff happening when it comes to CD, but now it's actually less. It feels like it's less, it's slower actually. You might feel otherwise, but when I was doing this research, I found that it's actually less stuff. And I'm not sure that it's actually like with the advent of GitOps, it's getting easier to get end-to-end view of the change for developers. So I'm a little bit concerned there, but we will see how the whole thing unfolds. And I tried to put it into perspective. So I went to the Google Trends, and this is how much people search for continuous delivery. So it looks like here we got a book, and the whole thing starts to take off. So it looks good, right? Well, we are the DevOps, and we could see that like the DevOps is going strong and like continuous delivery. Still, you take Kubernetes, you take Docker, and now the continuous delivery curve is like almost flat. So like if you put everything to perspective, there seems to be still a very little talk about continuous delivery, and maybe just people natively understand what it is. I don't know. Maybe there is like no reason to Google it. And I feel like personally that by 2015, we really got everything we need to do CI efficiently. So by 2015, doing CI became a no-brainer. We have like all the tools that you just flip a switch and you're doing CI with GitHub, Jenkins, Circle CI, whatever you have there. And we got, we got the good build system. We got the dependency management sorted out. We got a decent version control and easy branching. We got packaging. We got unit testing, kind of easy, and we got the CI server. So, like 2015, you can basically don't have excuse to do that. But it doesn't really feel the same for continuous delivery. It feels that, like, at least doing that research, I feel that from 2014, 2015, we started to look more and more into problems when it comes to deployment, making sure that our infrastructure is there, observability, monitoring. So we're solving the problems related to continuous delivery, meaning that it is still challenging to do continuous delivery because you come to any organization and you see that they have to tweak things around to make it work for them because it's not unified. They have their own things, like the ways of working are not the same. With continuous delivery, like, yeah, we do pull requests, whatever. More or less everyone does that. Continuous delivery is not the same. Well, the products are different. Maybe that's the reason, but it feels that there are still problems to solve in there. And this is a picture from DevOps Report. DevOps, how do they call it? service State of DevOps 2019. Here's a link in the bottom, and you could see like continuous delivery being in the middle. So we really need to fix a lot of stuff before we can start doing continuous delivery efficiently. And we got continuous integration, we got a little bit of automated testing, version control, deployment automation, monitoring. And like with all of that solved, then we could do continuous delivery, and then software delivery performance improves that, and also improve organizational performance. So there is a lot of stuff going on, but I'm not sure about it. I feel that a lot of people do continuous delivery, but when I see I'm trying to find information about, are they? It looks like not. So I'm personally a little bit confused, and you have to decide for yourself. Like we see the world through different lenses, and you probably see it differently. Maybe you are surrounded by cool guys, maybe like you work in a top end company like Google, Spotify, whatever, and continuous delivery is a normal part of your flow. Maybe you work in another organization where they even haven't heard about continuous delivery just yet. So depends where you stand. And looking ahead and some final thoughts, I would say stay focused and first ask, what is the problem you are solving? Like you got the GitOps, fine, but what is the problem you are solving? Shall I adapt the GitOps? What is the problem you are solving? How it will benefit your organization? Will it improve something? So don't rush after the tools, after the new shiny ways of working. Focus on solving the business need. Think about, will it make my life easier? Will it make life of my developers, of my organization? Will we be able to release faster and with more confidence? And if not, maybe you could just keep waiting and don't do the technology bad. But the change is inevitable, so it's going to be, we're going to change anyway. So what I would suggest, and this is what is safe to do, is take your pipeline and strip all the logic from your pipeline. Make your pipeline as just the outline of what step to call after what step, and maybe the general frame. So it's just a frame where you run the steps, and then take all the logic from your pipeline and put it into the Docker images. So for instance, you want to run Terraform, create a Docker image that would run Terraform for you, that you would have like entry point, for instance, like the /do script, and which would receive the inputs through environment variables, and you would just clone the repository in, run do, and it does it for you. And all the logic how you do Terraform is encapsulated within that image, because then you can run it anywhere. You can run it locally, your developers can run it locally, you have all dependencies inside. You can easily migrate from one CI/CD service to another because it's all in Docker container. And the only thing you need to change is this frame that's on top of that, it orchestrates how you call them. And that's probably a safe bet, I would say. And that would allow you to easily change between and be prepared to change in the future. GitOps, well, see for yourself, maybe experiment a little. It really depends. Prepare for the new needs. I mean, ML ops, machine learning operations, like building pipelines for the machine learning models, something new coming up. And we as automation engineers have to be prepared for that. So look, it's probably the same thing, probably the same tools, but a little bit of buzz around it now going on. So again, keep your head cold, think of what the problem you're trying to solve, and get to it. And then another thing that I would highlight is platforming of CI/CD capabilities. I see a lot of people, doing generating pipelines, doing the code generators for their pipelines. So it's easier for their developers. So they're trying to reduce cognitive load. And I think that's something that's important going forward, because then you're creating a new abstraction level and you can change a lot in the backend without developers being affected. So they can carry on doing the business related job or like delivering value to the business. And well, a little bit of plug. If you like what you hear, and if you can couple with my accent, then I started to do a little bit of podcasting together with my friends called DevOps Talks, available on Apple and Spotify and then Google Podcasts. It's just us friends talking about how we survive cloud native. There is no advertisement or anything, and we want to keep it this way. And totally unbiased, no tool vendors involved. We just talk what we think. So if you like it, well, please come over and listen. And with that, I would say thanks. Questions go to Slido. So if you have any, type there. And thanks for coming.